Okay, this is the third screencast for Investigation 11A, and this is actually where we're going to start Part B of the investigation. So you'll need to have your highlighter handy, and you'll need to be on 11A-4, so page 4 of your investigation. You'll also need to have your map that you glued together yesterday. You'll need to have that handy, and here we go. Alright, so I am starting up here, and I'll stop you in a minute, and there's a few things I want you to highlight. So it says the imaginary pressure blocks we have been examining can be employed in modeling ocean currents and finding relationships among water temperature, height of the sea surface, and ocean currents. We will do so by taking a closer look at the warm Gulf Stream that forms the western arm of the North Atlantic subtropical gyre. Okay, so let me stop there for just a second and bring this back in. Y'all remember this map? Over here, this is the Northern Atlantic, this is the South Atlantic. So they're saying that the Gulf Stream, here's this warm water current right here, here's the Gulf Stream. It forms the western part of this gyre. Okay, so here's the Gulf Stream. It starts kind of off the coast of Florida, comes up the east coast of North America, and then starts to kind of head over towards Europe. Okay, so that's where we are. Okay, our primary source of sea surface temperatures, okay, that's going to be abbreviated SST, so our primary source of sea surface temperatures of the Gulf Stream and the surrounding ocean is actually measurements made by infrared sensors flown on board Earth orbiting satellites. So how did we get the temperature data for the Gulf Stream? That's actually from infrared sensors on satellites taking measurements. Okay, so here's my copy that I actually am willing to highlight on. You might want to start here, taking note that the Gulf Stream is what forms the western arm of the North Atlantic subtropical gyre, and that our primary source of information about the temperature of the Gulf Stream comes from those infrared sensors that are aboard satellites. While we're making use of satellites' derived sea surface temperatures to study the Gulf Stream, we need to also realize that this warm water actually reaches hundreds of meters beneath the surface signatures. So what they're saying is it's not just the very, very, very top of the water that's that temperature. That temperature extends down for a while. Okay? Alright, and then this next section talks about the map. And basically, they tell you to make sure that you cut it apart and glue it together so that you have something that looks like this. Okay? Alright, relatively high sea surface temperatures delineate the Gulf Stream on this analysis. Well, what does the word delineate mean? Because if you don't know what the word delineate means, it's really not very helpful for me to say it delineates it. It marks it out, it outlines it, it sets it apart. Okay, so if you delineate something, you're setting it apart or marking its boundaries. Okay, so relatively high sea surface temperatures delineate the Gulf Stream. Okay, and all of these numbers, all these itty-bitty numbers that you see, 21, 21, 22, 23, these are all temperatures in degrees Celsius. Okay, and the thinly drawn curves mark water mass boundaries. So these little wandering lines show you water mass boundaries, boundaries between areas of water that have different temperatures. Okay. They give you several abbreviations, and I'm not going to have you worry about that too much, other than this one right here, GSS. That stands for the southern border of the Gulf Stream. GSN, that's the northern border of the Gulf Stream. Okay. So delineated by the GSN, the Gulf Stream North, and the Gulf Stream South borders, the northward flowing Gulf Stream parallels the coast from Florida to North Carolina eventually turning more eastward, and then looping generally northeastward across the Atlantic Ocean. So there's the Gulf Stream. And it says, starting in the Atlantic just offshore from Florida, use a red pencil to darkly shade the location of the Gulf Stream. Okay, so let's stop and do that real quickly. Okay, so here's Florida, and I said off the coast of Florida. So starting there, to shade with a red pencil this stream of water. This is a surface current known as the Gulf Stream. Okay, so you should wind up with something that looks similar to this, because this current right through here, this is the Gulf Stream. Okay? And just remember that GSS, that just marks that southern boundary of the Gulf Stream. Okay? Means Gulf Stream south. And GSN right here is marking the northern boundary of the Gulf Stream right here. Okay, so let's look at 11 and see if we can answer that question now. It says, east of Florida, the highest sea surface temperature in the Gulf Stream is what? Is it 24, 25, or 27 degrees Celsius? Well, here's Florida, and we're looking east of Florida, so we're looking in this area. We've got 26, 26, 24, 25, 26, 27, 27, 26, 25, 24. Okay, so what is the highest sea surface temperature in the Gulf Stream east of Florida? It's going to be 27. So make sure that you select that on number 11. Okay, according to the temperature scales on the map, this corresponds to a temperature of 81 degrees Fahrenheit. All right, what they're talking about is if you look down here, and you went over to 27 degrees Celsius, that corresponds to 81 degrees Fahrenheit. Number 12. Ocean water rings or eddies form when loops in the meandering Gulf Stream, remember that meander means to kind of wander around, ocean rings or eddies form when the loops in the meandering Gulf Stream break off to form isolated and persistent rotating bodies of water. Okay, so let's talk about first what isolated means, off by itself. Persistent, it continues, it doesn't stop. Okay, so eddies form when part of the Gulf Stream breaks off to form isolated and persistent rotating bodies of water. It's like a teeny-weeny little gyre, if you want to consider it that way. Their presence is evidenced by differences between their surface temperatures and the temperature of the waters surrounding them. On the Gulf Stream analysis, several warm eddies are identified. Okay? And all of the eddies, the typing's really small, but for instance, that one says W1104, so W stands for warm. This one is W, and I can't read the number because it's under my Gulf Stream north boundary. This one's W1105, so that's another warm eddy. Way over here is another one, W1102. Those are all warm eddies. Okay, little bits of swirling water that are warmer than the surrounding water. Okay. A warm eddy, W1104, is identified east of New Jersey at 40 degrees north and 61 degrees west. Okay, so if y'all know your geography, right here, this is New Jersey. So they're talking about east of New Jersey at 40 degrees west, 40 degrees north and 61 degrees west. This warm eddy is located on the cold water side of which boundary? The Gulf Stream north or the Gulf Stream south? Okay, so here it is. Here's the Gulf Stream. We've got to go across the northern boundary to get to this eddy. So it's on the cold water side of the Gulf Stream north boundary. So take your paper and make a note that it's on the Gulf Stream north side.